Good evening, guys. You are welcome to GMAETS 41's channel, your channel of excellence. So in this live class, I'm going to be exposing you to some wonderful secrets on the part of conic section, the parabola. So once again, welcome to this class. Once you join this class, you know how we used to do it. Like this live class right away. So just click on the like icon. Then quickly help GMAETS 41 to share the link to this class to your friends, to your course mates, to your departmental WhatsApp group. Invite them to join this wonderful class. All right. So we're going to look at parabola. Quickly, without wasting time, let's move. I want to sketch something on the board quickly. Okay. So let's say that I have my axis here. So let's take this as our y-axis. Then let me say that I have this as my x-axis. Okay, so we have y and x. Now this is very important because, like I always tell my students, we want to understand something about conic section. When you are dealing with conic section, good knowledge of graph plotting is what we carry you through. Okay. Now you notice that I am not really talking about definition of conic section in the first place. I have a wonderful video lesson, okay, a lecture video that covers that part. You can go through the playlist and take the lecture video on definition of conic sections, the types. There are 4 types. And the condition or value of eccentricity that would give us the conic section we are dealing with. We're just looking at parabola quickly. So I just want to tell you something very significant. Whenever you're dealing with conic section, a good knowledge of graph would carry you through. So if you know how to plot graph, using your x and y value to get or locate a point on graph, you shouldn't have problem with conic section. Now, there are actually 4 types of conic section, okay, but I'm only going to draw 2 here. So let us say that I have something like this. Let's say I have something like this. Good. I have something like this. This is my conic section. This shape is my conic section, okay. We're coming to talk about this particular conic section. Rather, is a parabola. I'm still going to tell you how you quickly identify a parabola in terms of its equation. Okay, now having done this, the next thing I'm going to do is to show you this. Maybe I will draw another one. Let me draw another one here. So we have x and then y-axis and then say x-axis. Good. Stay put. Share this link to your friends like I said. Please, they need to connect so as to get to understand this for what it is. Now, permit me to draw the conic section this way this time around. So this is my parabola. Okay. This is the shape of parabola. Like I said, there are 4 of them. Okay. Parabola can either lie open facing the positive y-axis, which is this guy. A parabola can lie open facing the positive x-axis, which is this one. A parabola can lie open facing the negative x-axis. In that case, this guy you are seeing here will be drawn to face down. Okay, will be drawn to face what? Down. I might decide to bring it to this negative axis of y. But this part called the vertex will now be on top, while the open side will now face down. So that parabola lies open facing the negative x-axis. Now, the 4th type is a parabola that lie open facing the negative x-axis. These are the 4 types. But I've just drawn 2 for you. That the 2 is sufficient for me to make my analysis as per what I want you to know. Is that okay? Good. Now, you want to understand something that I did not just wake up and draw this anyhow. It's assumed that I plotted a graph with some points, x and y value, to get this curve. So quickly, as a guiding principle, think about your quadratic equation graph, because a quadratic equation is actually a parabola. Okay, a quadratic equation is actually what I said, a parabola. So if you plot the graph, that shape you get is shape of a parabola. Now we're going to use this quickly to make key analysis as I unlock certain secrets about parabola, foundational knowledge you need, so that once your examiner gives you any question on parabola, you blast it. Are you following, right? Okay, so I'm going to show you something. Yeah, good evening. Welcome to the class. Welcome, all of you. Sorry, I have to get my other device to see if I can be able to, queue into the class so as to be tracking what is happening at your end. All right. So I have mentioned that we have 4 types of parabola. Before we move on into this class, let me show you the real shape of a parabola in real life. All of us know what an egg is. We know what an egg is. This is an egg. This is an egg. Don't mind me. I've eaten the content. But okay, let us assume that you have an egg. A complete shape like this is an ellipse. And take note, ellipse is one type of conic section. Just hope this device comes up. I need new device, so you guys can support me to get it. This one is messing up now. Right? It's messing up. It will take 30 hours before it pops up. Anyway, let's move on. Let's move on. Keep waiting. If it doesn't come up, once in a while, go to the back to check, what is happening at your end, to be sure that you're following up and you friends are connected to the class. All right, let me try to see. So like I said, an egg completely like this is an ellipse. And don't forget that ellipse is an example. It's one conic section, okay? It's a type of conic section because there are 4 of them, like I said: circle, parabola, ellipse, and hyperbola. All right, now, if I ask you to break this egg into 2, so I'm going to slice it into 2 now. Are you watching? Slicing it. I know you'll be laughing. You say, look at GMAETS. GMAETS have opened this already. Anyway, it doesn't concern me. I've sliced it with my hand. Can you see this? The slicing is not uniform, but it does not matter anyway. Let me say I remove this part a little. Okay. So can you see this now? Can you see this? Each of these is a conic section shape. Let me now use this guy. I think this device has come up, so let me see. Clicked on it. So this shape you're seeing is a parabola. A parabola. Please stay on, right? Let me put on Jen quickly. NEPA has done its own for what they are known for. So give me a moment. Give me a moment. Give me a moment, okay? Let me quickly put on light. I was bothered about this. I'm so sorry, guys. You can imagine how careless our power holding company can be in this country. Okay? Yeah, they are so careless. But we're always ready for that because we know that it is their festival celebration. Some people celebrate always. All right, let's get to business, please. No time. Let's get to business. I was showing you what a parabola looks like. Okay, parabola. Now, I'm also going to give you an example of this. Your lantern, lamp. The handle of lamp is also a parabola. Okay, it's a shape. It has a parabolic shape. Okay, so having shown you, a good example of parabola, I think this is okay. Now, if this parabola is like this, you can see the open side. If it is facing up, we'll say that, okay, the parabola is lying facing the positive y-axis. Now, if it is facing this side, like this one now, the first one I showed, like this, is facing up, positive y-axis. If it is open, facing x-axis, we say that the guy is lying open facing x-axis, positive x. Now it could go this way. Look at it. I hope you're saying this right. It could go this way. Negative x-axis. Now it could be open facing down. Let me be careful so that this stuff will not pour. In case it pours. All right. Okay. You see, it does stem me. Something like this. You can see this one. It's facing down. So we say that the parabola is open, facing what? The negative y-axis. So these are the 4 types of parabola. These are the 4 types of parabola. And I'm going to quickly now tell you what a parabola is, having told you or shown you what the shape of a parabola is. A parabola is simply a conic section of second-degree polynomial. Yeah, a parabola is a second-degree polynomial. A second-degree polynomial in x or a second-degree polynomial in y. Am I communicating? So I can say that a parabola is a conic section of second-degree polynomial in x or y. Which means if you're dealing with a parabola as a conic section, it is either x is carrying power 2. That is what I mean by second degree polynomial. Or y is carrying power 2. X and y cannot carry power 2 simultaneously. Take note of that. Both of them, x and y, cannot be raised to power 2 in the equation. It is either x is raised to power 2 or y is raised to power 2. Once again, take note of this because this will help you to differentiate between parabola, ellipse, circle, and hyperbola. So for parabola, it is a second degree equation in x or y. Therefore, I'm going to give you the equation of a parabola quickly as a conic section. I'm going to give you the equation of a parabola with respect to this guy. That is when it is open facing y-axis, either positive or negative y. I'm going to give you an equation of parabola, okay, which you are expected to memorize when it is open facing either positive x or positive y. So this is the equation. For this guy, it is lying open facing which axis? Y-axis. Like I said, either positive or what? Negative. When it is facing y-axis, the equation is given as x. Well, like put this. Okay, let me write it somewhere here. The equation is given as x minus h raised to power 2 equal to plus or minus 4p open bracket y minus k open bracket y minus k. So this is what the equation will be like. It is facing which axis we said? It is facing our y-axis, either positive or negative. So the equation would be this guy. Now you notice that when the parabola is facing y-axis, what will be carrying the square? The variable x will be carrying the square. I know you are worried, thinking h, p, k. Don't worry, that's why I took my time to draw this. Like I said, I am exposing the secrets of parabola. Once you're able to capture all the details in this class, and then we move on to calculation, you would find out that the calculation will now become 1 plus 1. But to tell you the truth, if you don't grasp this secret, this foundational secret I'm exposing, if you don't get it, then it becomes challenging to be able to solve questions on parabola. But of course, you know always from GMAETS 41, by the support and help we get from our helper and God Jehovah, I will do my best to explain these concepts for you. Okay, I hope this did not cut off from, okay, it showed. It didn't cut off. It didn't cut off. All right, let us move on. Trying to use this to track what is happening at your end. Let's see. And I hope you can see the board from there. I hope you can see the board clearly from there. All right, let us move on. So whenever a parabola is facing either y or either positive y or negative y, the equation of the parabola takes this form. What will help you is this. Parabola is facing y-axis, either positive or negative y. In the equation, mathematical equation of that parabola, the guy that will be carrying the square will be x. Does that make sense, right? Will be what? X. Now let us come to this guy. This parabola is open facing x-axis. Whether it is facing positive or negative x-axis, the equation of the parabola will take this format. Y minus k all squared equal to plus or minus 4p open bracket x minus h. This would be the equation. This will be the equation. In the case where it is facing which axis? X-axis. So you observe that when a parabola opens facing the x-axis, either positive or negative, the variable that we carry square will be the opposite axis, which will be y. Like I said, you are seeing k, you are seeing p, you are seeing h. Don't bother yourself much. You are coming to those concepts. I'm going to explain what those guys are. I'm going to explain them. Please invite your friends to join this class. Invite them. Your exam is fast approaching. Your exam is fast approaching, especially for our dear friends in Unizik. For others from others, in any case, every one of you offering maths needs to give attention to this. If you're offering math 102, or you're offering any maths that has conic section as a topic. Okay, so to those in Unizik, tell your friends they should join. Not when we are doing live revision, then you hear somebody say, hey, my God, can I be able to pass this course? When you have opportunity to learn this, make use of it. So don't go asking yourself whether you can pass the course or not. Listen, nobody cares whether you pass a course or not. No one cares. That's just what you want to be aware of. And that is why you want to work hard. And you have this channel that is helping you always. Whenever I have this opportunity, I upload anything or come on live. Make sure you connect. Make sure you connect. Nothing stops you. From the comfort of your home, you are learning what otherwise you might not even learn from your lecture. That's the truth. Yes, otherwise you might not be able to learn it from your lecture. So please share these links to your friends so that they can join. Now, I have told you what the mathematical equation of a parabola looks like when it is facing either positive or what? Negative x-axis. So as a summary, I hope this network is not disturbing. It's hanging somehow here. Juanco Martins on the rise, Divine Favor, Michelle Adinweruka, Faith Banner, and the rest, y'all, welcome to the class. Okay, invite your friends to join this class, and then give a like to this lesson so that YouTube can recommend it to as many others as possible as well too. Now, guys, you have known the equations of parabola. You've known what a parabola is. It is a conic section of second degree polynomial, either in x or y. A parabola is a conic section of second degree polynomial, either in what? X or y. And that's why you can see in this case, the x part is carrying power 2. So this is second degree polynomial in x. And that is true when the parabola is facing either positive or negative y-axis. You have the equation in this format. Then in this case, because the parabola is a second degree polynomial in x or in y. In this case, it is second degree polynomial in y. What is happening? In this case, it is a second degree polynomial in what? Y. Because the parabola is facing x-axis, either positive or negative. You notice that this 4p has plus or what? Minus, which now interprets the fact that the parabola can face either the positive or what? The negative axis, as the case might be. So you're expected to memorize these equations. Very important, okay? Memorize them. Now, before we move on further to any other analysis, I want to ask some educators, some teachers, some lecturers, do you think it is wise for us to teach scholars conic section on the assumption that either the center or the vertex is at the origin? It's at the origin, either the center. Center in the case of circle, center in the case of ellipse and hyperbola. Is it really wise for us to teach scholars assuming that the center is at the origin 0,0? What about parabola? Do you think it is wise? It is something really, really right if we really want to help scholars to teach them this stuff, like in the case of parabola, assuming that the vertex of the parabola is at the origin? As an educator, if you think it's wise, please, I want to tell you to abort that thought. All right, about that thought. It's not wise. We might be doing it. Even several textbooks also present it, approaching this conic section with the assumption that the center or the vertex of that guy, okay, center in the case of circle, ellipse, and hyperbola, then vertex in the case of parabola. Most times we approach it assuming that these guys are the center, at the origin. It is not advisable. If you look at what I drew here, I could have drawn this. I could have drawn this instead. Look at this. This one now, the vertex is at the origin, or something like this. The vertex is at the origin. However, why though it is not wrong, it's not wrong. However, it is not wise. Because my end up giving equations, like in this case now, the standard equation is x squared equal to plus minus 4p, then 4py, 4py. Whereas in this case, the equation is y squared equal to plus minus 4px. One can use either p or a here, it doesn't matter, any symbol can be used. If we do that, we have succeeded to give like 30% or 40% knowledge. Okay, let me just pity. We have succeeded to give 50% knowledge to the scholars and have ruined them by removing 50% knowledge from them, which means we made them, lose 50% understanding of what that particular conic section might be. So I am using this opportunity, please, to advise our educators, wherever you may be, lecturers, wherever you are, teachers, wherever you are. If you're teaching your students conic section, please, it is advisable you approach the interpretation, letting them understand the analysis when the center is not at the origin, or when the vertex in the case of parabola is not at the origin. If we do otherwise, we may end up teaching them, but they won't understand up 50 or 60% of the topic. All right, having said that, let me wipe this and then let's move on. You notice that I shifted the vertex of the parabola from the origin, and that is good. Now watch. This part is called the vertex. Let me label it. This is the vertex of the parabola. Vertex of the parabola. Okay, so here, this is the vertex. Does that make sense? I'm going to draw a central line. Okay, that central axis through the parabola. Look at it. Dot, 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 dot. This is a central axis. Here, you can also do that. Dot, 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 dot. This is a central axis, an axis that passed through, the center. Let me assume the center of the vertex, okay, that passes through the center of the vertex. Remember, like I said, it's not all about solving questions. It's not all about solving questions. Please, dear scholars, take notes. If you don't understand what I'm analyzing in this particular class, Questions can be given to you in parabola and then you get confused. Don't worry, as you follow up with calculation, you would see what I mean. The questions can be presented in different formats. Okay? So it's not just about solving questions. Understand is how, however the question is given, you can deal with it. So I have this. Now this is the central axis. Now I am going to draw another line. Look at this line. That line is called the latus rectum. Here, look at it. It is called the latus rectum. Latus rectum. Okay, either you call it latus rectum or you call it focal diameter. Or you call it focal diameter. Focal diameter. That's good. Take note of this line. Now, the point where it meets the central axis, we call it the focus. We call it the focus. Permit me to use F. Okay, let me use S as the focus. Permit me to use S as the focus. You can use any other symbol you want. S. So where the point, okay, the point where the central axis met the focal diameter, that point is called the focus. So we know the vertex already, and I've labeled the focus. Like in this case, is the vertex. That's good. Now, you know that the vertex is a point on that parabola. Look at this point is the vertex. And you know that to locate a point on a graph, you use x and y value to locate it. You use x and y value to locate it. All right, before we start locating this point, let us draw what we call the directrix. Directrix in conic section is a fixed straight line. Directrix in conic section is a fixed straight line. And then focus in conic section is a fixed point. Focus in conic section is a fixed point. And you know that whenever you have a point in Cartesian plane, you know, your x and y axis, you can locate that point using x coordinates and y coordinates. We are moving. Let us now draw the directrix. Like I said, the directrix is a line drawn on the opposite axis, parallel diameter. This is the latus rectum, also called the focal diameter. Let me label this. This is the focus. The focus. You have to know all these things. So look at it also, the focus. Then this line is called the focal diameter. This line is called the focal diameter. Let me call it latus rectum. Latus rectum. Otherwise called the focal diameter. Now, like I said, the directrix is a fixed straight line drawn on the opposite axis to the focal diameter, to the latus rectum. So I have the latus rectum here. The directrix will now come to the opposite axis. The latus rectum is between positive y and positive x axis. On the opposite axis, okay, opposite side of that latus rectum. So I'm bringing the directrix to this negative x and to this positive x and negative y. And it's going to be parallel. It is going to be parallel to the latus rectum. So this guy, we call it the directrix. 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 How could someone solve questions on parabola when you don't know the meaning of all these things and how you even get there? Now look at the directrix. Let me extend the line. Let me extend the line. This is the origin, 0, 0. In fact, let me indicate it, 0, 0, the origin, the origin. So look at the directrix. If you extend it, you notice that the directrix crossed y-axis at this point. At this point. So we can write the directrix equation that at this point, the directrix equation is, remember, it is a value on y-axis. So it's going to be y equal to minus p. It's going to be y equal to what? Minus p. Don't worry, I am still going to tell you what that p is. We are moving gradually. In this case, this second one, the directrix will be this, a line drawn on the opposite axis to where you have The latus rectum. This is the latus rectum, focal diameter of this parabola line facing positive x-axis. So if I want to draw the directrix will be a line drawn parallel on this side. Look at it, something like this. That's the directrix. Consider the directrix is parallel to the latus rectum, the focal diameter, and it is on the opposite side of that focal diameter. So in this case, this is my directrix, like I said. Okay, directrix. Okay, I've labeled it synonym. The network interfered. I'm sorry, you have to manage this. That is why, please make sure you follow up with my uploads. You notice that I reduced much of live classes within this period, but there are regular uploads on this channel. If you have not subscribed yet, make sure you subscribe, turn on the notification bell and select all, so that once I upload any content, you will be notified. Lots of calculations on the Conic section will come as pre-recorded lecture video already because of network interference most times. Okay, so please take note of that. Show you certain things you need to know. Let us now identify these points. Like I said, this is the vertex. We are going to be using V as the vertex. We're going to be using what? V as the vertex. We're going to be using V. Now, your examiner would want you to know how to identify the coordinate of the vertex. Remember, I said there are two key things, parameters, that your examiner might be so interested in your getting. One, the focus of the parabola, and then two, the vertex of the parabola. It does not mean that you can't be asked any other thing. You can, but I'm telling you, basically, these two guys, very important. How do you identify, how do you get their coordinates? Like if I want to get this point now, this vertex, how do I obtain it for this parabola? If I want to get this vertex, how do I obtain it for this parabola? That is why I said that it is really not ideal. It is not ideal to analyze a parabola assuming the vertex to be at the origin. It's not usually ideal. It's not. But if we do this point, which is the vertex, is somewhere away from the origin. Look at it. If I want you to locate this point now on your graph, what will you do? I give you this point, I want you to locate it. What will you do? It is simply to come to this point, then you trace dot. You trace it to the x-axis. So this gives us a vertical height. This gives us what? A vertical height. A vertical height. And that vertical height is the value, is the coordinate of the vertex along the y-axis. That vertical height is the coordinate of the vertex along the y-axis. It is just like somebody giving you something like this. I gave you something like that. I say you should locate this point. Locate this point. What would you do? At least from our physics practical work, you know, we've done a lot of stuff on physics practical. So locating a point on graph is no longer a problem. Yes, that is my confidence, except if you've not been doing what you're supposed to do. If I want to locate this point on the graph, what I would do is trace this thing down, dot. You get a vertical height, but that vertical height will give you a particular value on x-axis. From here to here will be a particular value on x, let's say x1. And then from here, you take it dot to the y-axis. From this point to this point, you have your y, let's say y1. Now, you notice that along the perpendicular, the y-axis, from here to here, you have a vertical height. And from here to here, you have a horizontal distance. So the same thing, if I want to locate this vertex, if I want to locate this vertex, this point, get the vertical height from here to here, get the horizontal height length from here to here. So let me measure, dot. So I've gotten from this point, dot to the vertical. So measuring from the origin to this, you get a vertical coordinate. Then you now notice that from here to here, you get a horizontal coordinate. So this is what we do. We label from this point to this point, we label it as H. We label it as H, which means from the origin to where you have the vertex, from the origin to where you have the vertex, the length along the horizontal axis is H. And that, of course, is what brought this H here. So what is GMAT for the one trying to say in essence? I'm telling you that this H here is simply the x-coordinate of the vertex, the coordinate of the vertex along the x-axis. From here to here. From here to here. Are you seeing it right? Then the coordinate of the vertex along the y-axis is from the origin to this point, because when I dotted this line here, you notice that it came out here. And if you measure from the origin to this point, you get a vertical height. That vertical height, we are going to label it as K. We are going to label it as what? K. Which means that K you are seeing here is vertex. This K you are seeing here is the y-coordinate of the what? Vertex. Which means, network, please calm down. Network, calm down. The network is just busy breaking and hanging. So back to this K. If you look at this K, is a vertical height from the origin. And so if you measure from the horizontal up to this point, you would get your vertex. So our K is the y-coordinate, the vertical coordinate of the vertex. Therefore, if your examiner asks you to get the vertex of a parabola, the network is just trying to mess this class up. Just keep hanging and hanging and hanging. Please manage up. Okay, just manage up. If your examiner asks to find the vertex, it simply means find the horizontal and the vertical coordinates of the vertex, which is H, K, like I said, and I've shown you what your H, K, is. The position of the vertex measured away from the origin. Now, observe this now. If the vertex is at the origin, let us assume I carry this vertex and I bring it to the origin. Once this vertex is at the origin, H, K will now become 0, 0. It's network. Look at what I mean. Assuming that you are dealing with a parabola, that the vertex is at the origin. Now look at the vertex. Okay? You notice that this vertex is at 0, 0, which means V, which is H, K, will now be equal to 0, 0. This is true if the vertex is at the origin. But if the vertex moves away from the origin like this, it is no longer 0, 0. That was why I actually suggested, as a way of advising, that educators, if need be, should not be teaching conic section assuming the vertex of a parabola or the center of a circle, ellipse, or hyperbola to be at the origin. It's not advisable. It's not. It would make students to lose focus or get confused whenever a problem is given where the vertex is no longer at the origin. Don't worry. This week, there are going to be a series of questions on conic sections. Follow up and you will see, what we are going to do on it. Okay, now, we are done with the concept of the vertex. Let us now move on to the focus. How do we obtain the focus? By the way, before we talk about the focus, let me even tell you about this 4P. This 4P is the length of the lactus rectum. This 4P is the length of the lactus rectum, the length of the focal diameter. Lactus rectum or focal diameter, its length. The length of the focal diameter of the lactus rectum from here to here is your what? 4P. Does that make sense? 4P is the length of the lactus rectum. This is hanging again. This is hanging again. I don't know. I don't know. Let me still fire up the network a little and see. The network is really, really disturbing. No. The network is just not giving up to allow me have a successful class. That's annoying. But of course, I wouldn't give up. I would have to expose this secret foundation, like I said, so that going forward this week, I'll be releasing, questions, soft questions. But make sure you understand all these things I'm trying to explain. The network is still messing up, busy hanging and hanging and hanging. Gosh. All right, let us move on. We now want to talk about the focus. I've told you that this 4P represents the length of the latus rectum, the focal diameter. That is what 4P is. Now, permit me to wipe this, and then I want us to write out the equation of the coordinates of the vertex is h comma k, like I said, vertex coordinates equal to h comma k. So you want to take note of this. And like I said, if the vertex is at the origin, then h comma k will be 0 comma 0. We are done with that. I told you that this 4P is the length of the latus rectum or focal diameter. So focal diameter or latus rectum, length of latus rectum, length. I'm squeezing this. Okay, let me wipe that. Length of latus rectum. Is equal to 4P. Talk about the focus coordinate or coordinate of focus. Coordinate of focus. The focus I'm using S. So how do we get the coordinates? Now to proceed, the first thing we have to do is to know the length or the height from here to here. From the vertex to the focus, the length is P. From the vertex to the focus, the length is what I said, P. So permit me to label it here. Permit me to label it for you. Somewhere here. Good. This height from here to here is what? P. So let me write P. From the vertex of a parabola to the focus of a parabola, that length is P. That is what this thing is. All right? So if that length is P, it simply means that the focus measured from the origin, for example, in the case of this parabola, what I'm analyzing here is exactly the same thing you do here. So to locate this focus from the origin, it's going to be the height from the origin to the vertex plus the height from the vertex to the focus, which of course is simply K plus P. K plus P. But take note, that is when the parabola is facing the vertical axis, either positive or negative y-axis. K plus P. If the parabola is facing this x-axis, either positive or negative x-axis, take note that our measurement, look at, let me even quickly show you here. From the origin to the vertex, say, look at the vertex, dot, 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 dot. Look at it, look at it, look at it. This length is h. If you come to the vertical height, from the origin, dot, 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 to this point where this vertex touched y-axis. That height is k. That height is k. Then, if you now measure from the vertex to the focus, you notice when the guy is facing, when the parabola is facing the x-axis, either positive or negative x-axis. Measure from this vertex to this focus, you get your P. So I will come over to this and then measure from here to here. Okay, where do I show it? Look at from this point to this point. That is your P. I can show it here. That is your P. Which means if the parabola is facing the horizontal axis, either positive or negative, if you want to locate the focus, measuring it from the origin to the vertex is already H. And then from the vertex to the focus is P. So the focus measured from the origin would simply be H plus P. When your parabola is facing x-axis, that which makes use of this equation. But if the parabola is facing y-axis, the coordinate of the focus in terms of the vertical will be K plus P. But don't forget that the focus also has horizontal coordinates. Look at the focus here. If I ask you to locate that point using x and y value, what will you do? X and y value, first, the x value will be measured from this point, dot, 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 dot. It will touch here. Then to get the x value, what will you do? Measure from the origin to it. From the origin to that point is H. Then the focus measured on the vertical axis, dot, 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 to get the coordinates. You take it from the origin down to this point. So the vertical coordinate of the focus from the origin is now going to be from here to here, which is K, plus from here to here, which is P. So the whole idea is this. The focus along the horizontal, along x-axis, the coordinate will be H. Along y-axis, the coordinate will be K plus P. If the parabola is facing y-axis, that which makes use of this equation. But if the parabola is facing your x-axis, either this way or this way, observe now, what is going to be the horizontal coordinate of this focus, the x coordinate of this focus? Look at it. Measure from the origin is going to be from here to here, which is H, plus from here to here, which is P. So the horizontal coordinate, the x coordinate of the focus for this particular parabola facing x-axis will now be H plus P when it is facing x-axis. Then the vertical coordinates, look at it, dot, 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 dot to this point, measure it from the origin. From the origin to that point is going to be K. Therefore, you have to know two formulas or two coordinates of the focus whenever you're dealing with parabola. One, with respect to when the guy is facing the vertical y-axis, and two, when it is facing x-axis. So let us conclude it. Coordinate of the focus would be equal to, first, let me analyze this. When it is facing what? The vertical. If it is facing the vertical, the horizontal coordinate will be H, comma, and then the vertical coordinate will be K plus P. K plus P. Now permit me to write or. Why this or? When it is facing the horizontal now. Take note, this is where it is facing. Will not, comma. And then the vertical coordinate of the focus will simply be what? K. That is the analysis. That is the analysis. And I guess we are done with the concept of parabola. The only thing left when analyzing parabola now is with respect to maybe talking of the relationship between the directrix, the focus, and the point that generates. The directrix has a relationship to the point that generated the conic section, being parabola, and the focus. I think I won't have the time or the space to actually write that equation there. But what I want to say simply is that this guy you are seeing here, if you move this P to the right hand to the left hand side, or in this case, you move it to the left hand side, okay? You move P to the left hand side. The square of the x plus or minus P you're going to get there. Square of x plus or minus P. Say you have something like this. Plus or minus P. The square of this guy will be equal to the distance PS. Will be equal to the distance PS. Distance PS. And distance between 2 points, you know the formula using coordinate geometry. It makes use of Pythagoras theorem, you know. It makes use of what? Pythagoras theorem. In fact, let me see if I can squeeze it here. Okay, having written PS first, the distance PS, can now write x plus minus P all squared will now be equal to square root x minus, that is x2 minus x1 all squared plus y2 minus y1 all squared. This equation, you met it under coordinate geometry. I will still wipe this because it's making this dirty. But I've given you the idea. There is this type of question you might be given under parabola that will require you to know the definition of conic section. Are you following? Conic section is defined as the locus of a point that moves in such a way that the ratio of that point measured from the focus to that point measured from the directrix will always give you a constant, and that constant is called eccentricity. That constant is called what? Eccentricity. Don't worry, I'm going to solve a question on that when we come to the question part of this. Like I said, you need to understand how all these points are generated and what they mean when you are dealing with conic section. Just take note of this. Eccentricity of a parabola. Eccentricity. Eccentricity of a parabola. Eccentricity E of a parabola is equal to 1. Is equal to 1. So from there, the distance of that point that generated the parabola to the focus divided by the distance of that point that generated the parabola to the directrix will give you a constant, which is eccentricity, and that eccentricity for parabola will be equal to 1. Like I said, the full lecture video on this explains this concept of conic section definition, which I just gave you here. We use it to solve certain questions under conic section. Parabola as an example. Are you following? But basically, I think your examiner will test you more on what I showed you on the board. But I've been able to expose all the secrets as for how you obtain all this. Are you following, right? All this H, all this K and P, what they mean whenever you are dealing with your conic section. Remember, all the points traced here, how I obtained them for this particular parabola is the same thing here. So use the knowledge here to analyze this guy. Still any other thing to talk about? Nothing significant. What you need to know in order to be able to handle parabolic equation, I have analyzed it. So, going further, we are going to deal with questions on parabola. I'll solve only one question in this class. But make sure you stay tuned to GMAT 41. You see what network has done to us already. This could have been a very wonderful and sweet class as always, although it is still sweet. Like I said, I'm never frustrated by all this nonsense that has been done in our country. It's nonsense. NEPA, power holding company will do theirs. Network will do, its own as well. But all the same, I just understand the weather. The weather now isn't really funny from our end here, from this part of the world, with respect to life class fully. But we'll continue to manage. And of course, like I said, we have pre-recorded video lessons. You can always follow through. So if you have not subscribed, make sure you subscribe. Turn on the notification bell so that whenever I upload any pre-recorded video, because of course from tomorrow they will start appearing questions on conic section, calculations on there. Okay, you will be notified once I upload any one. If you subscribe, turn on the notification bell, select all so you don't miss out on any updates. Now, finally, before I pick any particular question, remember I told you if the vertex is at the origin, what is going to happen? Then h comma k, which is the coordinate of the vertex, will now be 0 comma 0. Take note. If the vertex is here, if this vertex is at the origin, look at it, this vertex, if it comes to the origin, of course, h and k will no longer have any distance because they will all come to the origin. So h comma k, which is the coordinate of the vertex, will now be 0 comma 0. In that case, what will this equation become? I'd like you to work on it from your end. Fix 0 here, you get x squared. Is that not so? Fix 0 here, you get just 4py. Come here, do the same. You get y squared equal to plus minus 4p times x. Come to the focus. If the vertex hk is at the origin, h will be 0. So this will be 0 comma, then k will be 0. 0 plus p will now give you the value of p. So it's going to be 0 comma p. This one will be p comma 0 if the vertex is at the origin. And this requires that you should know how to solve problems on completing the square method in mathematics. I repeat, completing the square method in mathematics. Remember that parabola is a second degree equation in x or y. And our second degree polynomial is simply quadratic. And whenever I have quadratic, you know, you can complete the square. So like I said, we're going to pick only one question. Only one question in this class. I have wonderful thing I want to be doing for you in a just short video series starting from tomorrow. So make sure you stay tuned. Please, if you want to snap this, you can screenshot if you've not copied it already. Okay. If you've not copied what's on the board, you can screenshot so that I can round off what we have there. Copy out what is on the board. You might decide to screenshot, better for you. Okay. All right. So I'm going to be wiping this, assuming that you have screenshotted it. Like I say, dear friends, remember, solving questions on this is not a problem. And this is one of the things I wanted to talk about, you know, things that students should know as per effective learning. Because I know that most of you are looking, solve question, solve question. It's not about solving question. If I solve one question on parabola and I decide to give you another one, you might just be confused without your understanding this basis, this foundation. So you want to be careful of how you learn. Do not overrush. Do not what? Overrush. Get the foundation. And the rest will follow naturally. I'm going to wipe this. Like I said, they'll pick just one question. And remember what I told you, please. If you do not know how to solve quadratic equation by completing the square method yet, please, please, and please, I'm begging you now. When your examiner gives you a question, nobody will beg you. Make sure you go and practice how to solve questions, quadratic equation by completing the square method. On this channel, you have wonderful lecture video that covers it, okay? So you can check through Math 101/Math 102 playlist. Don't forget that this focus is when the parabola is lying on what? Y-axis. It's facing Y-axis. And this one when it is facing what? X-axis. I hope we are still on. Right. So I need to replace it. But I don't have money to replace it for now. Support this channel. Okay, you can join GMAETS 41 on the platinum or diamond level. That will be appreciated. So support this channel. The channel keeps growing and continues to give you the best. Meanwhile, I want to thank you all so much, dear subscribers, dear channel members. GMAETS 41 is highly impressed by the support that I'm getting from you guys regarding this channel. The support that this channel is getting, it's super wonderful. Thank you very much. Okay, don't give up. Continue to do more. Appreciate it. Just like I'm doing more. So I've got this question here, right? The question is, identify, or let me say, name the conic. Name the conic name the conic and the coordinates of the focus and vertex. Of the focus and what? Vertex. Name the conic and the coordinates of the focus and vertex given below. And so we have plus 3x minus y equal to 5. So you have to name this conic. You are to name this conic. And then, of course, find the focus and the vertex. It's a simple work based on what I have taught you so far. This is 1 plus 1. First of all, observe that this is a second degree polynomial in x. This is a second degree polynomial in what? In x. This network, you started again. This is a second degree polynomial in x. It is only x that has power 2 here. Y does not have power 2. Y does not have power 2. So this is clearly a what? A parabola. Because it is only parabola as a conic section that either x will be raised to power 2, y will not be. Or y will be raised to power 2 and x will not. So what do? We're going to rewrite this as we have x squared plus 3x. Now this y, move it to the right hand side. That's going to be y plus 5. Why are we doing this? Remember that for parabola, it is either x raised to power 2 is subject to the formula, or the y part raised to power 2 is subject of the word formula. The idea is that the guy bearing power 2 must be written to be subject of the word formula. You have to separate the x from the y. That is the secret. That is the idea. Am I communicating? In this question, I want to modify it somehow. Is it necessary to modify? Is it necessary to modify it? Okay. Let me leave it. Let me leave it. Like this. Now from here, you have to play around this equation. Why? The reason being that in a parabola, the standard form is such that you don't have x raised to power 1 if the x term is carrying square. If the x square is carrying square, you are not expected to see x raised to power 1 in that equation. You can see the trick there. Remember this equation? X minus h all squared equal to plus minus 4p, then y minus what? H. So if the x term is carrying square, you are not expected to be seeing x raised to power 1 in that equation. So we want to do something to this 3x raised to power 1 so that we will not be seeing that x raised to power 1 there. This parabola you are seeing here is of this form. Does that make sense? It's of this form. Look at the other guy. Y minus k all squared equal to plus minus 4p x minus h. This is y minus k, please. X minus h. You notice that the y term is carrying power 2. So in the equation, you will not, you wouldn't see anywhere where you have y raised to power 1 anymore. In that equation, you won't see any y raised to power 1 existing on its own, since the y term is carrying square. So that is the secret. Come here. You must make sure that you are not seeing this x raised to power 1. So you play around this guy. And that is where completing the square method comes into play. This is x raised to power 2 plus 3x. Because you have power 2 of x raised to power 2, and you have x raised to power 1. In quadratic equation, you can complete the square. You can do what I said, complete the square. So let us complete the square. And how do you complete the square? Watch, let me show you the fastest trick. How you handle this in exam. In completing the square, find half of the coefficient of this x raised to power 1. Half of this 3 is simply 3 over 2. You are meant to square it and add it to the left and to the what? Right hand side. Like I said, if you do not know how to complete the square method yet in quadratic equation, please, you have to learn it before you enter exam hall where you are taking questions or exam that you likely are expecting conic section. Of course, that is true if the course you are offering has conic section as a topic in it. Please go and learn your complete the square method. This channel has it already to help you if you need help. Still any question? What's the time there? Nice. Keep on growing, sir. Thank you very much, H. The time here is 10:43 p.m. That's 17 to 11 p.m. 17 minutes to 11 p.m. We'll still be rounding up. This is the only question we are solving. So I'm going to find half of this coefficient of x. Half of it is 3/2. Now, watch one fastest thing you can do to the left-hand side. That half, which is simply 3/2, add it to this x. Add it to this x because of this plus. If it is minus, it's going to be x minus that half. Minus half of that coefficient of x. This guy, the coefficient here is +3. So half of this is simply 1/2 times 3, which is simply 3/2. And it is positive here, so it's going to be plus. If it is minus, maintain that sign. You write minus. So in this case, it is plus. So simply, I'm going to now bring that 3/2. I will add it to this x directly. X plus 3/2. This x is carrying square. So you enclose these two in bracket and then you square it. I have completed a square on the left-hand side. This will now be equal to, once you do this x will no longer appear. The x will no longer appear. The reason is because if you expand this guy, if you expand this, it's going to give you this term. If you expand x plus 3/2, all in bracket raised power 2, it's going to give you back x squared plus 3x. So since this term is equal to what you have on top, good. Don't just stressing yourself anymore. It means you have been able to succeed in clearing off x raised power 1. You are no longer seeing any x raised power 1 ordinarily there because it now appears in square form. Now let us move on. Remember that half of the coefficient of this x is 3/2. And we say you have to square it and add it to the left and to the right. I've already added to the what? Left. But the way it works on the left is simple. You won't show the square on that 3/2 directly. You won't show it directly to add. Pick that half of that coefficient of x, which is 3/2, like I said, add it to this x directly, then enclose in bracket and put square. Because this x is carrying square and that 3/2 is also carrying square. So enclose them in bracket and square both. If you expand it, like I said, it's going to give you back this. So you are mathematically consistent. You are correct. Move to the right-hand side. You have y plus, come to this is 5, y plus 5. Remember, in completing that square, you must add to the right-hand side square of that half of the coefficient of x. So 3/2 square. Add it to that right-hand side. So we now have x plus 3/2 equal to, if I come over to this is going to be y. Simplify this term. If you simplify this term, what are you going to get? This is going to give you 9/4. And if this is 9/4, you can work out the LCM of this term. You can work out the LCM of this term. 9/4, the LCM is going to be, let's do it once. 9/4, the LCM is going to be 4. So 4 times y will give us 4y. 4 times 5 will give us 20. 4 times 9, that 4 will be divided by the 4 under. Remember, like I said, this 3/2 all square is 9/4. And then the LCM is 4. So if that 4 is to multiply this term, the denominator 4 will cancel it. So you are now left with 9. So this is going to be plus 9. Everything will be divided by what? The LCM 4. So this will now be work on this. This is 1/4. This 4 you have here. 1/4. Then open your brackets. If you add up this, what are you going to get? If you add up this, you're going to get 29, right? You're going to get what? 29. And if you get 29 there, this is simply 4y plus 29. This 1/4, the over 4 is this guy here, this denominator 4. This is going to be a little problem for us because we need to do certain factorization. You know, I just worked out this question. I just gave it to you. I am meant to give something we could solve out. We're supposed to have a term that can factorize from here. Because normally this 4, the coefficient is meant to be 1. The coefficient is meant to be what? 1. So I'm meant to factorize a common term from here, which must be a coefficient of this. So this question I gave, there is a small challenge there. There's a small challenge. You know, I just work out, let's solve this and see. There's a small challenge there. There's a small challenge there. I'm meant to factorize 4 out from here. This y is not meant to bear any other factor. It is not meant to bear any other coefficient rather. So let us see. I think I have to rework on this question, like giving you something that can be solvable. And I've just told you these two terms, we are meant to factorize something out. Like this 4 shouldn't be here anymore. If this 4 is meant to be here, then this 29 is meant to have been something that can be factorized, that 4 can be factorized out. I'm trying to see how we achieve that. If I had made this guy to be 2, if this were to be 2, half of it to be 1, 1 square, I come here and then add it, I would be getting 6 here. So this is going to be y plus 6. Y plus 6. I think that is better. Or I make this 4, and then this is going to be 2 here. And if it is 2, as in 4x, this will be 2. If this is 2, if I square that 2, take it to this side, adding it to this 5, is going to be 9. And then if it is 9, that's cool. I think that's better. That's better. Sorry, I didn't test this question. It just came up and I just had to give it. Do you get that right? Like I say, follow through from tomorrow where I'll have a tested question given to you. So for this guy, we had to touch it a bit. I just wish this 9 was not there. Or maybe it is something that if I add it, 4 could have factorized. So let's see. What if I had written this as 5? Let me see. This will now be 5 squared 25. 25 over 4. This will be 30. 4 cannot divide 30. As in 4 cannot come out from 30. 4 cannot come out from 30. I'm trying to do something such that we don't change this stuff too much. What will I do? 5 squared is 25. 25 plus 5. It's going to give us 30. This will be 4 already. Factorize it, it won't work. If it is 6, 6 squared, okay, 6 over this, we give you 3. Square 3, be adding 14 to this. Please, I'm sorry that something like this happened. I'm going to change this, let's say to 4. Mind you that for any question given to you, it is already tested. It's already tested. Starting from tomorrow, you're going to see wonderful questions. Please, half of this guy, I'd wanted to still leave it as a fraction. But if I do 8, 8 squared is 64. 64, add 5, you get 69. 9 squared is 81. 81, add 5, you would get, add 5 to 81, you would get 86. Can 4 come out from 86? 86 divided by 2 is 43. It's not going to work out. So what if I made this thing? This is 9 already. So what if I made this 6? 4 times 6 is going to give us 4 times 6 is 24. Right? Then add 24. Add 24 to 9. You get 33. 4 cannot factorize still. 4 times 7 is 28. Add 28 to 9. This is dangerous. All right, like I said, please, guys, we've got no choice. I'll leave this as 4. So come over here, please. Okay? At least. Now, I'm looking for half of 4. Half of 4 will give us 2. So this is going to be 2. Fix 2 here. Fix 2 here. You know, if the half of 4 is 2, you have 2. That 2 has to be squared. So what I'm meant to add here is 2 square. So let me remove this and fix 2 square. 2 and then square. So this whole term will go off. I have to solve something that is correct. This question, there is a challenge, a problem with it. With respect to that factorization will have issues. So this is going to give us 2 here. So coming over to this is 9. So this is y plus 9. Good. This is y plus 9. So I'm going to enclose this in brackets. See that what I was telling you, that the coefficient of y is meant to be 1 whenever you solve this and simplify completely. The coefficient of y is meant to be 1. If it is not 1, whatever number as coefficient you have here has to be factorized out. Has to be factorized out. Except when I had that 4, but I could have divided through by 4. I think this was, let's see, 4y plus 29. Oh no, oh no, oh no, I made a mistake. I made a mistake. It's not funny, is it? Somehow crazy sometimes. When I didn't test that. There was something I didn't see, and that is where basic maths is very important, please, for you to take note of. Basic maths, you don't joke with it. And then observation. I foolishly didn't observe something here, that was a silly mistake by me. I am going back. Let me go back. We're going to solve it. I think I just quickly observed something. Sorry about that. So leave it as 3. So this becomes 3 over 2. This becomes 3 over 2. This becomes 3 over 2. Good. Then I think when I worked out on this, we had 3 over 2. Sorry, there was something I didn't do. See? Then we squared this. So we're dealing with LCM of this. And I said that 3 squared is 9. 2 squared is 4. So this is 9 over 4. The LCM is 4. So working out LCM of this part, 4 times this will give us 4y plus 4 times this will give us 20. Then here, if you work out, use the LCM to multiply the numerator. The denominator 4 will cancel out for, then 9 will be left. Then all over 4. And then I could write this as 1 over 4, but it's a waste of time. Look at this is 29 already. If it's 29, permit me to write it 4y plus 29 all over 4. This is good. So this was where I made a mistake. I shouldn't have factorized this immediately. No, it's not necessary. So with this is going to be 4y plus 29 is the same as 4y over 4, which will give you y. Then plus 29 over 4. 29 over 4. That's good. So this is the correct work. This is the correct work. Okay? So we have y plus 29 over 4. If you split this numerator over this denominator, like I said, the coefficient of this y, that term raised to power 1, whenever you standardize the equation, that term raised to power 1, the coefficient must be 1. And this is how we achieve it. So from here, we can now get the vertex. The vertex is this guy added to this x here, and this one added to this y here. So I can write, this is a parabola, like we said, parabola because it's a second degree equation in x. So obtaining my vertex, coordinate of the vertex. Vertex will now be equal to, come here. Do you remember that the equation I gave to you as the equation of a parabola when it is facing y-axis? There, the x term will be squared. That equation is x minus h all squared equal to plus minus 4p, then y minus k. This is the equation. If you compare this with this, you will notice one small difference. This is plus instead of minus. From the formula, it is meant to be minus. From the formula, it is meant to be what? Minus. And here it is plus. You must convert this plus to minus. You have no choice. That's the standard. You must convert it to what? Minus. I hope this did not cut off. Okay, it's showing. You must convert this to minus. And how do you achieve this to become minus, just like you have in the standard equation? Plus can be written as minus minus, watch it here, x plus 3 over 2, same as x minus minus 3 over 2, then all raised to power 2. Which means that your h there, look at it, is minus 3 over 2. So come over here, the vertex h comma k. Vertex h comma k is equal to minus 3 over 2 comma the h coordinates. Then the y coordinates, come over here, this is 29 over 4. This is plus. It is meant to be minus. So you write this as minus minus 29 over 4. So this is going to be minus 29 over 4. Correct. So we have obtained this value. The next one is our focus. The next one is our focus. I think I'm also going to solve something here. Just trying to manage this space. We don't have enough space here. I don't want to adjust the camera. So let us go to the focus. We have obtained the first one, answer of the vertex. So to get the focus, what do we do? What do we do to get the focus? Can I obtain the focus here? Let's see. Let's see. Good. I think I can manage this space for focus. Now remember that the focus is equal to this parabola is lying on which axis? How would you know the axis that this parabola is facing? Since the x squared term is bearing square here, sorry, the x term rather is bearing square. This variable x is bearing square. And y variable is not bearing any square. It's not. It means that the parabola is facing y-axis. The parabola faces the axis opposite to the one bearing square. X is bearing square. So the parabola faces what? Y. If it is y that is bearing square, then the parabola will be facing what? X-axis. So this parabola is facing y-axis. That is why it is the x term that is bearing square. Therefore, the focus is going to be, since it is facing y-axis, the focus is now going to be h, k plus p. This something plus p is going to be on y-axis, since the parabola is facing y-axis. If the question given to us, the square term, assuming that that square term is y, then the parabola will be facing x-axis. And hence, the focus will now be h plus p, k. So let us proceed. We know our h already, look at it. We know our k already, look at it. Our problem now is p. How do we obtain our p? Simply come here. To get your p, you look at the coefficient of this part that is not bearing square. Of course, you can see it here, 4p. So what is multiplying this part that is not bearing square? Invisible 1. Invisible 1. Invisible 1, 4p. That is the length of the focal diameter, or the length of the latus rectum is 1 here. And that 1, if you compare it to this equation, is 4p. So if 1 is equal to 4p, you can now calculate p. P will be 1 over 4. Which means that our focus will now be equal to h, which is minus 3 over 2. Then, comma, k is minus 29 over 4. You are adding p to it. And what is your p? I repeat again. To obtain your p, come to that part that is raised to power 1. That part that is not bearing square. Look at the coefficient. Equate it to 4p. So if 1 is equal to 4p, p will be 1 over 4. So this is going to be plus 1 over 4. So simplifying, we are going to get minus 3 over 2. The focus will now be equal to minus 3 over 2, comma. LCM here is 4. So simply add up the numerator. Minus 29 plus 1 will give you minus 28. Minus 28 divided by 4 will give you minus 7. Minus 7. So this is the solution of the focus of this parabola. It's quite interesting, good enough. I was able to quickly detect, what I was actually omitting in this calculation. It could have been a disaster, Perhaps someone will look at it and say, what? So GMAT 41 made this mistake. You guys can be so funny. They say he doesn't know what he's doing. But we are humans. We are human. Even if, assuming I didn't quickly kind of notice that silly mistake I made, if I had not noticed it, I only tell you that makes me a human. But thanks to God that I noticed it. Before you people will start, you forget all the good that I've been doing and then focus on that. So this is how cool we solve this question. You see, when I was interpreting the concept of vertex, h, k, okay, this and that, the focus, h, k plus p, telling you that the p will be added to the k coordinate, to the y coordinate, which is k. I didn't need to talk much. When I was telling you 1 equal to 4p, I didn't need to talk much because I had already explained and established this concept from the basics. So with this class, the GMAT 41, your natural intelligence assistant, has fully exposed everything you need to know about parabola. From tomorrow, I'll be solving super cool questions on these guys, right? Some will come out as video, others will come in the YouTube short section of this channel. Stay tuned. If you have not subscribed, once again, I am appealing to you, subscribe. Turn on your notification bell. When you click that notification bell, select all. This thing I've told you is free of charge. You don't pay anything for it. And I told you, for payment on this channel, in order to become channel member, join on platinum level, join on diamond. That one is just there. But subscribing and then turning on notification bell is free of charge. Even membership package that is platinum or diamond is monthly. It's not every week. It's not every day. It's monthly. All right. For the platinum, is 2,000 naira Nigerian currency monthly. For diamond, is 4,000 naira Nigerian currency monthly. Support me, I will appreciate. Support me. I greatly appreciate that. And yes, I need it. We all need support, right? So that the channel can be growing, so that I will take care of myself. I'll get necessary gadgets also necessary to always give you the best. So thank you for connecting to this class, and it's been a wonderful time with you, friends. This is where we bring the class to an end. 4 minutes after 11. I really didn't think that this class is going to last up to this time. I really wanted it to be like 30 minutes maximum, but network frustrated. Did it frustrate us? No, we refused to give up. So network interfered. Network interrupted us much. I was not even too bothered about Power Holding Company because I had a backup. It was network. All right, guys, I'll be seeing you in my next video. Remember, love from GMAETS 41. Love you guys. Always want the best for you. Take your studies seriously. Take your lectures at school seriously. If you're taught anything at school you don't understand, and you know that this is something that GMAETS 41 does, come to this channel. Come to this channel. Your natural intelligent assistant dedicated to help you improve the network of your brain, and you will get the help that you need, because our help comes from our God and helper Jehovah. And as you learn this, you're going to go in there and get that A splash for GMAETS 41, for yourself, for your parents, and everyone together with yourself will be proud of yourself. All right? Good night. Enjoy your sleep and dream about parabola. Don't dream any other thing. Dream about parabola. Not even about the question I solved, but the secrets I exposed. How you locate all those points. What all those points mean in terms of graphical work for parabola. Okay? When you talk of H, K, P, what do they mean? How do you get the length of the focal diameter? Get to know all those bases, those foundations. Once you know them, the calculation is just 1 + 1. But finally, remember, you're completing the square method.